What if I told you that right now, at this very moment, a visitor from the edge of our galaxy is sailing through our solar system? A silent wanderer that has been traveling for millions of years through the frozen darkness of space, carrying ancient secrets about worlds we've never seen. And the most incredible part? We only just discovered it. This is the story of 3I/Atlas, the cosmic messenger that changed everything we thought we knew about our place in the universe. Welcome back to another episode of Cosmic Dreams, where we explore the mysteries of space as your journey into restful sleep begins. I'm your guide through the stars, and tonight, we're venturing into one of the most extraordinary astronomical discoveries of our time. So settle in, find your comfortable position, relax those shoulders, and let the wonder of the cosmos gently carry you toward peaceful dreams. Part 1. The Discovery. Imagine this. It's July 1st, 2025. Somewhere in the mountains of Chile, a sophisticated telescope system called ATLAS, the Asteroid Terrestrial Impact Last Alert System, is doing what it does every night, scanning the sky, searching for objects that might threaten our planet. But on this particular night, something extraordinary caught its attention. Something that shouldn't have been there. Something that shouldn't even be possible. The astronomers realized they had stumbled upon something unprecedented. This wasn't just another comet from our solar system. This was an interstellar object, a visitor from beyond our sun's family. And not just any interstellar object. This one was a comet, blazing with activity and leaving a trail of cosmic dust in its wake. Let that sink in for a moment. For billions of years, this object journeyed through the infinite darkness between the stars. It survived cosmic radiation, extreme cold, and the crushing emptiness of interstellar space. And then, almost by pure chance, a cosmic coincidence that happens perhaps once in our lifetime, it arrived at our doorstep. The discovery was officially announced on July 2nd, 2025, and the astronomical community erupted with excitement. Why? Because 3I/Atlas is only the third interstellar object ever confirmed in human history. The first was Oumuamua in 2017, a mysterious object that still puzzles scientists. The second was Comet 2I/Borisov in 2019. And now, here was the third, arriving to teach us even more about the universe. The name 3I/Atlas tells us everything we need to know. The 3I means it's the third interstellar object on record. The Atlas honors the telescope system that found it. It's also officially cataloged as C/2025N1, a non-periodic comet, which means it follows a hyperbolic orbit. Simple translation? Once it leaves our solar system, it's never coming back. This is a one-time visit from the depths of space. Part 2. The Journey. Where did it come from? Now, you might be wondering, where did this cosmic traveler come from? Who is its parent star? What solar system gave birth to this wanderer? The truth is, we don't know. Not exactly, but scientists have some fascinating theories. Based on the comet's trajectory, the path it's taking through space, astronomers estimate that 3I/Atlas likely originated somewhere in the outer regions of our own Milky Way galaxy. Some believe it could have come from what's called the thick disk of our galaxy, a region where older stars cluster together in the galactic suburbs. If that's true, then this comet could be ancient. We're talking about 7 billion years old. That means this icy object was wandering through space since before our sun and Earth even existed. It's like holding a piece of cosmic history in your hands, a time capsule from the ancient universe. Think about it. While our solar system was forming, while Earth was still a hot ball of molten rock, while dinosaurs would eventually walk our planet and vanish, this comet was already traveling through the dark void. And it kept traveling, through countless millennia, through cosmic storms of radiation, through the depths of interstellar cold. It survived everything the universe could throw at it. The reason we believe it came from outside our solar system is simple but elegant. The comet's orbit is what we call hyperbolic. That's an astronomical term that basically means it's on a trajectory that can only exist if an object came from interstellar space. It's moving too fast to be trapped by our sun's gravity. It's just passing through, like a cosmic hitchhiker catching a ride before moving on. Scientists calculated that 3I/Atlas is moving at approximately 30 kilometers per second, That's about 67,000 miles per hour. That's faster than any comet from our solar system. It's traveling at what we call the solar system's escape velocity, which means once it leaves us, the sun's gravity won't pull it back. It's heading home to the galaxy, carrying memories of its visit. Part 3. The approach, the comet's grand entrance. Now, let's talk about what happened as 3I/Atlas approached our sun. What did this ancient wanderer do when it felt the warmth of our star for perhaps the first time in billions of years? As the comet drew closer to the sun, something remarkable began to happen. The heat started to awaken it. You see, a comet is essentially a giant cosmic snowball, a mixture of ice, rock, and dust. When a comet approaches the sun, that heat begins to vaporize the ice. The frozen gases, carbon dioxide, water ice, and other chemicals, begin to transform into their gaseous forms. This creates what astronomers call a coma, which is basically an enormous atmosphere surrounding the comet's core. For 3I/Atlas, this coma became absolutely massive. By September 15, 2025, the coma had grown to an incredible 180,000 kilometers across. That's almost half the distance from the Earth to the Sun, and it was still growing. Scientists using the most powerful telescopes began to detect carbon dioxide gas spreading across a truly vast region, at least 348,000 kilometers in radius. That's visible in infrared light, which our eyes can't see, but our instruments can detect with remarkable sensitivity. What's particularly fascinating is that the comet became more and more active as it approached. In July 2025, astronomers noticed something interesting. The coma had a reddish tint. This reddish color typically indicates dust, tiny particles ejected from the comet's nucleus. And here's where it gets really interesting. The reddish color actually intensified throughout July. The dust composition was changing. The comet was evolving, transforming under the sun's influence. Scientists using precise measurements calculated that 3I/Atlas was ejecting enormous amounts of material. Small dust particles, just 1 micrometer in radius, that's incredibly tiny, were being ejected at a speed of 22 meters per second. Meanwhile, larger dust grains were moving slower, about 2 meters per second. But the volume was staggering, about 6 kilograms of small dust particles every single second, and 60 kilograms of large dust particles per second. That's like watching a mountain of material vaporize and disperse into space. The tail grew larger and larger. By the end of August, it had stretched to about 56,000 kilometers in length. By September, it had grown to an even more impressive 100,000 kilometers. And scientists predicted, correctly, that it would continue to grow as the comet approached its closest point to the Sun. Part 4. Perihelion, the climactic moment. October 29, 2025. This date marks a celestial milestone. This is when 3I/Atlas reached what astronomers call perihelion, the point in its orbit where it comes closest to the Sun. At its closest approach, the comet came within about 203 million kilometers of the Sun. For perspective, Earth orbits at about 150 million kilometers from the Sun. So 3I/Atlas was actually closer to the Sun than Earth is for much of the year. And at this moment, the comet was moving at an absolutely tremendous speed, about 68 kilometers per second. That's nearly 152,000 miles per hour. It was moving so fast that the Sun's gravity, despite its immense pull, couldn't slow it down enough to keep it in the solar system. The comet would just keep accelerating and then eventually leave us behind. This was the comet's brightest moment. At perihelion, 3I/Atlas reached a brightness of about magnitude 9.5 to 10. Now, if you've ever looked at the night sky, you might know that brighter numbers are lower. It's a backward scale. Magnitude 10 means you'd need a decent telescope to see it, but you could see it. Astronomers around the world positioned their most sophisticated instruments, the Hubble Space Telescope, the James Webb Space Telescope, Mars rovers, space probes, all focusing on this one object. And here's something truly remarkable. NASA revealed that 15 different space missions observed 3I/Atlas. 15. From the James Webb Space Telescope orbiting Earth, to the Perseverance rover on Mars, to the Lucy asteroid-studying probe, to the Mars Reconnaissance Orbiter. Scientists even pushed instruments beyond their normal capabilities to capture this moment. It was like the entire NASA fleet was converging on one target, all witnessing this ancient visitor's greatest moment in our solar system. The images were astounding. In visible light, you could see a faint but definite tail. In infrared light, captured by the James Webb Space Telescope, you could see the vast carbon dioxide envelope surrounding the comet. In ultraviolet light, captured by spacecraft orbiting Mars, you could see the comet's chemistry revealed. Different wavelengths of light told different stories about this ancient object. NASA officials noted that it was an extraordinary moment. It looks and behaves like a comet, and all evidence points to it being a comet, NASA's Associate Administrator Amit Kshatriya said during the official briefing in November. But this one came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. Part 5. The Mystery, Addressing the Cosmic Rumors. Now, I'd be remiss if I didn't address something. After 3I/Atlas's discovery, the internet exploded with theories. Some people speculated that it might be an alien spacecraft. Some suggested the government was hiding information about it. Some claimed it posed a threat to Earth. These theories spread across social media like wildfire. The reason these rumors emerged is actually quite understandable. 3I/Atlas is genuinely unprecedented. It came from outside our solar system. Its arrival was somewhat mysterious. And during October, when the comet reached its most active phase and was flying behind the sun, NASA was temporarily shut down due to a U.S. government shutdown. This timing fueled speculation. Conspiracy theorists asked, if it's just a natural comet, why is the government being so quiet about it? Well, NASA answered that question directly in November when they released the massive collection of images. And the answer is straightforward. 3I/Atlas is indeed a natural comet. There's no alien spacecraft here. No government cover-up. Just real, fascinating science. How do we know? Because the comet's behavior is perfectly consistent with how comets behave. Yes, some unusual accelerations have been detected in its trajectory, what we call non-gravitational accelerations. But here's the thing, many comets show this. It's called the rocket effect. When a comet's gases and dust are vaporized and ejected into space by the sun's heat, they act like tiny rockets, pushing the comet slightly in different directions. This is completely normal. It happened with Oumuamua. It happened with 2I/Borisov. And now it's happening with 3I/Atlas. The chemistry is also entirely consistent with comets. Spectroscopic observations, analyzing the light coming from the comet, revealed the presence of carbon monoxide, carbon dioxide, water vapor, and cyanide molecules. These are typical compounds found in comets from our solar system. There's nothing exotic here, nothing that defies explanation. In fact, what's remarkable is how much 3I/Atlas resembles its predecessor, 2I/Borisov. Both comets show similar activity levels. Both have shown reddish dust. Both exhibit similar chemical compositions. This actually helps scientists understand that these objects follow consistent physical laws, regardless of which stellar system they came from. So here's the truth, presented with complete confidence. 3I/Atlas is not a threat. It's not a spacecraft. It's not harboring alien technology. It's a comet, a beautiful, ancient, precious comet, but a comet nonetheless. And that makes it no less amazing. Part 6. The Chemistry, Reading the Ancient Stories. But here's where the story becomes truly fascinating. While 3I/Atlas is indeed a comet like others we've studied, its composition tells an incredible story about its origins and its journey through space. Scientists analyzing the spectrum of light from 3I/Atlas made a surprising discovery. This comet contains significantly more carbon dioxide and carbon monoxide than typical comets in our solar system. This abundance of carbon compounds provides important clues. The leading theory is that 3I/Atlas's surface has been altered by galactic cosmic radiation during its billions of years of travel through interstellar space. Think of it like this. The comet's surface has been weathered by cosmic rays, high-energy particles streaming through space, for an incredibly long time. These particles have been slowly transforming the comet's composition, converting certain chemicals into carbon compounds. It's like a very slow, cosmic weathering process that takes billions of years. This makes 3I/Atlas something like a time capsule from the ancient universe. The alterations to its surface chemistry tell us about the environment it traveled through. They tell us about cosmic radiation levels throughout the galaxy. They provide data that helps us understand how materials change over time in interstellar space. Additionally, scientists detected surprisingly strong signatures of nickel in the comet. This is notable because it suggests that nickel-bearing minerals are distributed throughout the comet's composition. Again, this is similar to what was found in 2I/Borisov, suggesting that certain elements might be common in comets formed around other stars. The water ice in 3I/Atlas is also interesting. Comets are fundamentally frozen reservoirs of water and other volatiles. Studying the amount and form of water ice in 3I/Atlas helps astronomers understand how water, one of the universe's most fundamental molecules, is distributed in star systems beyond our own. When the James Webb Space Telescope observes 3I/Atlas again in December 2025, scientists expect to obtain even more detailed composition data. Webb, orbiting 1,000,000 miles from Earth, can analyze light in infrared wavelengths with unprecedented precision. It should reveal even more secrets about this ancient visitor's chemistry. Part 7. The size, hidden in dust and mystery. One question that remains partially unanswered is, exactly how large is 3I/Atlas? Scientists haven't been able to determine the comet's nucleus size with precision. The nucleus is the solid, icy core at the heart of the comet. The problem is that the comet's nucleus is obscured, hidden from view by all the dust and gases surrounding it. It's like trying to see a person in the middle of a massive dust storm. You can observe the dust storm, but the person inside remains invisible. Based on their observations and calculations, astronomers estimate the nucleus could be anywhere from a few hundred meters to a few kilometers across. That's a pretty wide range. It could be as small as a mountain or as large as a small asteroid. The uncertainty doesn't diminish the comet's significance. It just means we have more to learn. What we do know is that despite this uncertainty in size, the comet's atmosphere is absolutely enormous. The coma has been measured at up to 180,000 kilometers across. The extent of the carbon dioxide gas envelope stretches across 348,000 kilometers. That's an incredibly vast region of vaporized material coming from what might be a relatively small nucleus. This dramatic difference in scale, a compact nucleus producing such an enormous atmosphere, is one of the remarkable features that has captivated scientists. Future observations using the most powerful ground-based telescopes and space instruments should eventually provide better estimates of the nucleus size. Hubble images from July 2025 provided some constraints based on the coma's brightness and shape, but more precise measurements will require continued observation and analysis. Part 8. The Gallery of Observations, Science in Action. Let me paint a picture of the astronomical effort mobilized to study this comet. It's genuinely inspiring. When NASA released images on November 19, 2025, they came from an incredible array of platforms. The Mars Reconnaissance Orbiter, a spacecraft that has been circling Mars since 2006 searching for signs of water, captured some of the closest images. Its camera, called HiRISE, High Resolution Imaging Science Experiment, snapped pictures of 3I/Atlas as it passed relatively close to Mars in early October. These images showed the comet with remarkable clarity. You could see the structure of its coma and tail. The Perseverance rover on Mars, famous for searching for past life on the Red Planet, turned its Mastcam-Z camera skyward and captured images of 3I/Atlas on October 4th. The rover, designed to explore Mars, became an astronomical observatory, observing a visitor from interstellar space from the perspective of a different planet. How poetic is that? The MAVEN orbiter, which studies Mars's atmosphere, captured ultraviolet images that revealed details about the comet's chemistry and structure that aren't visible in regular light. Beyond Mars, the Solar Terrestrial Relations Observatory, a pair of spacecraft orbiting the Sun, observed 3I/Atlas passing nearby. These sun-monitoring instruments provided additional perspectives on the comet's tail and behavior near the Sun. The Psyche spacecraft, on its way to study a metallic asteroid, observed the comet from 33 million miles away and captured 4 images over the course of 8 hours. These observations helped scientists refine their understanding of the comet's trajectory. The Lucy spacecraft, en route to study asteroids, managed to image 3I/Atlas from 240 million miles away. By stacking multiple images together, scientists could extract additional detail about the comet's coma and tail structure. And then there's the James Webb Space Telescope, perhaps the most famous observatory in the world right now. Using its near-infrared spectrograph, Webb examined 3I/Atlas, revealing composition data invisible to human eyes. Webb was designed to look at the most distant objects in the universe, galaxies from billions of years ago. But it's also versatile enough to study nearby comets, providing data of unprecedented detail. The regular Earth-based telescopes also played a crucial role. The Vera C. Rubin Observatory, a newly commissioned facility, serendipitously imaged the comet during its science validation observations. In fact, if this observatory had started its observations just 2 weeks earlier, it might have been the first to discover 3I/Atlas instead of the Atlas survey. Scientists from around the world contributed. The European Space Agency's Mars Orbiters, Trace Gas Orbiter, and Mars Express observed the comet during its closest approach to Mars. China's Tianwen-1 orbiter also managed to image the comet. Indian astronomers from the Physical Research Laboratory used ground-based telescopes in India to observe and analyze the comet spectrum, identifying the same molecular emissions seen in solar system comets. This global, multifaceted observation effort demonstrates something beautiful about human nature. When something truly extraordinary appears, we cooperate across borders, agencies, and organizations to understand it. Science brings us together. Part 9. The Cosmic Radiation Story. Billions of years of weathering. I mentioned earlier that 3I/Atlas's surface has been altered by cosmic radiation, but let's explore this concept a bit deeper, because it's genuinely fascinating. Throughout the galaxy, streams of high-energy particles, cosmic rays, are constantly flowing through space. These particles originate from various sources: supernova explosions, active galactic nuclei, and other cosmic cataclysms. They're traveling at nearly the speed of light, carrying tremendous energy. For billions of years, as 3I/Atlas journeyed through interstellar space, these cosmic rays have been bombarding its surface. Over such vast timescales, even particles moving at light speed have a cumulative effect. The cosmic rays transform the outer layers of the comet, breaking apart some molecules and creating new chemical compounds. It's slow, incredibly slow, but relentless over billions of years. What emerges is a kind of cosmic archaeological record. The comet's chemistry, altered by eons of radiation exposure, tells us about the radiation environment in different regions of the galaxy. It tells us about how long the comet was exposed to radiation. It provides data about galactic processes that are difficult to study any other way. When we compare 3I/Atlas to 2I/Borisov, we see similarities in this radiation signature, suggesting that both comets may have traveled through similar regions of the galaxy, or that the radiation environment is fairly consistent across large distances. This is cutting-edge science. By studying how interstellar objects change due to cosmic radiation, we're learning to read the universe's history books. Every comet that visits us from the stars is bringing news from distant parts of the galaxy, news that has taken billions of years to arrive. Part 10. The Dance of Numbers, Trajectory, and Timing. Let's talk about some of the precise numbers, because the mathematics of orbital mechanics is its own kind of poetry. 3I/Atlas reached perihelion, its closest approach to the Sun, on October 29, 2025. At this point, it was traveling at approximately 68 kilometers per second. That's 152,000 miles per hour. The Sun's gravity was pulling hard, but the comet's inertia and speed were too great. The Sun couldn't hold onto this visitor. As the comet continued outbound, its speed gradually decreased. By the time it reached Mars's orbital region, it had slowed somewhat, but it remained moving far faster than any natural solar system comet. The closest approach to Earth is calculated to occur on December 19, 2025. At that moment, the comet will be approximately 1.8 astronomical units away. An astronomical unit, or AU, is the distance from Earth to the Sun, roughly 150 million kilometers. So $1.80 translates to approximately 270 million kilometers. That's almost twice the distance from Earth to the Sun. In astronomical terms, that's relatively close, but in human terms, it's impossibly far. There's absolutely no chance of collision or any gravitational interaction strong enough to affect Earth. NASA and the International Asteroid Warning Network have confirmed this officially. The comet will then continue its journey outward. By March 16, 2026, it's expected to cross the orbit of Jupiter, the giant planet far beyond Earth. And after that, it continues traveling outward, eventually leaving the solar system entirely. It will spend the next tens of thousands of years, or perhaps millions of years, traveling back through the void toward home, slowly cooling, gradually drifting through the darkness. The speed is so great that the sun's gravity can never turn this comet around. The comet's trajectory is what we call hyperbolic. It's essentially open-ended. Unlike Earth's circular orbit or even the highly elongated ellipses of some comets, this hyperbolic trajectory means the comet is here once and then gone forever. Part 11. The Interstellar Family, Comparing the Visitors. 3I/Atlas is the third confirmed interstellar object to enter our solar system in recorded human history. Let's briefly meet its predecessors and understand what makes them special. The first was Oumuamua, discovered in October 2017. The name Oumuamua is Hawaiian, meaning a messenger from afar arriving first. It was discovered by the Pan-STARRS telescope in Hawaii. Oumuamua was initially puzzling because it appeared to be an asteroid, but its motion suggested it came from interstellar space. Its highly elongated shape, possibly cigar-like or pancake-like depending on the analysis, made it unique. Some scientists even joked, partially in jest, partially seriously, that it might be a solar sail from an alien civilization. Most astronomers, however, believe it's a natural object with an unusual shape. Oumuamua has since traveled far beyond our solar system and continues its journey through the galaxy. The second was 2I/Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov in Crimea. Unlike Oumuamua, 2I/Borisov was clearly identified as a comet from the beginning. It had a visible tail and coma. 2I/Borisov provided our first confirmed look at an interstellar comet, and studying it gave scientists crucial insights into how comets from other star systems behave. Many of the observations and measurement techniques used to study 2I/Borisov were refined and applied to 3I/Atlas. And now we have 3I/Atlas, discovered in July 2025. It combines features of both previous visitors. It's a genuine comet like 2I/Borisov, but it also shows some unusual properties and behaviors. And crucially, it arrived with enormous amounts of observational capacity trained on it. Our instruments have become far more sophisticated since 2017 or 2019. Scientists estimate that interstellar objects might pass through the inner solar system roughly once per decade, on average. But actually detecting them is challenging because they're so far away and moving so quickly. The fact that we've found 3 in just 8 years might be luck, or it might mean we've improved our detection methods significantly. Either way, it's wonderful news for astronomy. Each interstellar object teaches us something new. Each one expands our understanding of what exists in the vast spaces between the stars. Each one is a teacher arriving from the infinite cosmos to share its knowledge with us. Part 12. Why this matters, the significance. You might be wondering, why should we care about this comet? What does it matter whether a lump of ice passes through our solar system or not? Well, the significance is profound. First, 3I/Atlas is direct evidence that comets exist around other stars. We've theorized this, but having a physical sample is entirely different. This comet carries information about how planets and comets form around distant suns. It tells us that the processes that created our solar system, the formation of planetary systems from clouds of dust and gas, are likely common throughout the galaxy. Second, this comet traveled billions of miles through interstellar space and survived. It wasn't destroyed by cosmic radiation or collision with debris. This tells us something about the durability and resilience of icy bodies. If such objects can survive such journeys, then perhaps the ingredients for life, water, ice, and organic compounds, can be transported across vast interstellar distances. It opens fascinating questions about how chemical precursors for life might spread across the galaxy. Third, studying 3I/Atlas helps us understand galactic chemistry. The alteration of the comet's surface by cosmic radiation tells us about radiation levels in different regions of the galaxy. The abundance of certain chemical compounds tells us about the materials available in distant star systems. It's like having a sample from another part of the galaxy. Right here we can study it up close. Fourth, these observations represent the cutting edge of astronomy. The technology mobilized to study this comet, the James Webb Space Telescope, Mars rovers doubling as astronomical observatories, spacecraft billions of miles away turning their instruments to observe this one object, demonstrates human ingenuity and our ability to do remarkable things. It's a reminder of what we can accomplish when we work together with advanced technology and curiosity. Finally, and perhaps most importantly, 3I/Atlas reminds us that the universe is vast, mysterious, and full of wonders we haven't yet discovered. It reminds us that we're not alone in the cosmos, that other star systems exist out there, and that the universe is far more interconnected than we sometimes imagine. A comet from another world has visited us, and in doing so, it has expanded our perspective on our place in the cosmos. Part 13. The beauty of uncertainty, mysteries remain. Even with all our sophisticated observations and measurements, mysteries about 3I/Atlas remain. And that's actually beautiful. We still don't know exactly where it originated. We have educated guesses, perhaps the thick disk of the Milky Way, perhaps another region of our galaxy, perhaps even from a nearby star like one of the stars in a nearby system. But we can't pinpoint its origin with certainty. We still don't know its exact size. It could be a few hundred meters across or several kilometers. It could be a relatively small object or a significant one. The dust obscures our view. We still don't fully understand all the chemical alterations its surface has undergone. While we know cosmic radiation has changed it, the complete chemical history of this object remains partially mysterious. We still have questions about its nucleus. What's under all that dust? Is it a solid, icy body? Or could it have a more complex internal structure? And we don't know what other interstellar objects might be out there, approaching our solar system, that we haven't yet detected. 3I/Atlas was a fortunate discovery, but how many others have we missed? These uncertainties aren't failures of science. They're invitations to further discovery. They're the frontier, and frontiers are where true exploration happens. As you're settling into sleep, thinking about this ancient wanderer drifting through our solar system, consider this. We live in an age where we can detect objects coming from other stars. We can photograph them. We can analyze their chemistry. We can measure their speed and trajectory. We can coordinate observations across the entire solar system. We can peer into their composition with space telescopes orbiting millions of miles from Earth. Yet mysteries remain. The universe is still vast and wondrous. There is still so much to discover, and that should fill you with a sense of wonder and peace as you drift into sleep. Part 14. The Safe Departure. No Threat to Earth. Let me address one more thing clearly and directly. There is absolutely no threat from 3I/Atlas. None whatsoever. Some people have worried about collision. Some have speculated about gravitational effects. Some have even suggested the comet might harbor dangerous material. Let me put all of these concerns to rest. The comet's minimum distance from Earth is approximately 270 million kilometers, almost twice the distance from Earth to the Sun. At that distance, even if the comet were to shed all its material, that material would arrive at Earth as a diffuse cloud, completely harmless. The comet has no magnetic field. It's not radiating any dangerous particles. It's not going to collide with Earth. The probability of collision is literally zero. It's not even a possibility according to our orbital calculations. NASA has officially confirmed this. The International Asteroid Warning Network has confirmed this. Observatories worldwide have confirmed this. When thousands of independent scientists and institutions all reached the same conclusion, you can be confident in that conclusion. As 3I/Atlas continues its journey outward, it will eventually leave the influence of the sun's gravity. It will drift back into interstellar space, eventually becoming imperceptible even to our most powerful telescopes. It will join the vast population of wandering interstellar objects drifting through the galaxy. Objects we can barely detect, objects that represent the vast unknown space between the stars. This is a moment to savor, not fear. We've been visited by a cosmic messenger. We've studied it. We've learned from it. And now we'll bid it farewell as it returns to the cosmic frontier. Part 15. The Philosophical Perspective. Our Place in the Cosmos. As we wind down this journey and prepare for sleep, let's reflect on what 3I/Atlas means to us on a deeper level. For most of human history, we believed Earth was the center of everything. We thought our solar system was unique. We thought our sun was special. Gradually, astronomy has been teaching us a different lesson. We're part of something vast, interconnected, and wonderfully democratic. The stars aren't so different from our sun. The planets around other stars aren't so different from Earth. And the comets drifting between the stars aren't fundamentally different from the comets in our solar system. 3I/Atlas is an ambassador from this realization. It's traveled billions of years to deliver this message. You are not alone. Other worlds exist. Other suns have systems. We are all part of the same cosmic family. This should fill us with humility, but not despair. Humility because we're tiny, our solar system is young compared to this comet, and our knowledge is limited. But not despair, because it also means we're part of something vast and magnificent. We're connected to the stars. We're made of stardust. The atoms in our bodies were forged in stellar furnaces. And now, a visitor from a distant star system has come to say hello. When you sleep tonight, perhaps think about 3I/Atlas drifting through space. Think about the billions of years of journey it has taken. Think about the countless objects like it, traveling through the darkness, rarely meeting anyone, rarely being observed. And think about how fortunate we are to live in an age where we can notice such visitors, where we have instruments sophisticated enough to study them, where we can collaborate across the entire world to understand them, where we can ask questions about their origins and begin to answer those questions. We are living in the age of cosmic discovery, and 3I/Atlas is just one chapter in an ever-expanding story. Part 16, the final. So here we are, at the end of our cosmic journey tonight. 3I/Atlas has become not just a comet, but a symbol of humanity's connection to the universe, a symbol of our curiosity and our capability, a symbol of how vast and wondrous the cosmos truly is. This ancient wanderer has traveled for billions of years, carrying secrets from distant star systems. It has passed through our solar system, and in doing so, it has reminded us that Earth is not the center of the universe, but merely one beautiful world among countless others in an incomprehensibly vast cosmos. But here's the truly inspiring part. We're awake to this reality. We're conscious. We're observing. We're understanding. We're part of a species that can look up at the sky and comprehend what we see. That's remarkable. As 3I/Atlas continues its journey back to the stars, it carries with it our observations, our data, our questions, and our wonder. In a sense, we're sending part of ourselves back out into the universe through this comet. Our curiosity is traveling with it across the cosmic void. And yes, there's mystery here. Yes, there's uncertainty. Yes, there are questions we haven't yet answered. But that's not a failing. That's an invitation. That's the promise of future discovery. Every mystery is an opportunity to learn, to grow, to expand our understanding. The universe is speaking to us through 3I/Atlas. It's telling us that we live in a cosmos far richer, far more complex, and far more wonderful than we might have imagined. It's telling us that we're never truly alone, that other worlds exist, that other suns shine on other planetary systems, and that connection between them and us is real and tangible. As you drift off to sleep after this cosmic journey, I want to leave you with a question. And this is something I hope will tickle your imagination as you rest. What if, somewhere out there in the vast darkness between the stars, another civilization is watching the same sky, looking at the same stars, wondering about life on distant worlds? What if they're asking the same questions we're asking? What if, in some way, the act of our mutual observation and wonder creates a kind of cosmic connection? We don't know. But 3I/Atlas is proof that connection between distant worlds is possible. Objects can travel between star systems. Messages can be carried by the cosmos. The universe is more interconnected than we once believed. So I invite you, dear viewers, to continue this journey with us. Subscribe to Cosmic Dreams and join our community of cosmic explorers. Every week, we venture into the mysteries of space. We ask the big questions, and we explore the wonders that surround us. And if you have questions about 3i/Atlas or any aspect of space and astronomy, please leave them in the comments below. What aspect of this cosmic visitor fascinated you the most? What questions do you have about interstellar objects? What mysteries of space would you like us to explore in future episodes? Thank you for joining us on this peaceful journey through the cosmos. May your dreams tonight be filled with wonder. May you find rest and peace knowing that you're part of something vast and beautiful. And may you awake tomorrow with renewed curiosity about the universe that surrounds you. This is Cosmic Dreams. Until next time, keep looking up, keep wondering, and keep dreaming. The universe is waiting for you. Good night and sweet cosmic dreams.